use a table of values to estimate the value of the limit. And the limit that we're looking for is the limit as x approaches 2 of the quantity x to the 8th minus 256 all over x squared minus 4. Now, since we're looking at the limit as x approaches 2, we're going to want to look at some values of x that are less than 2, like 1.5 maybe, 1.9, 1.99, and 1.999. These are values that are approaching 2 from the left on the number line. And we also want ones that are greater than 2, such as 2.5, 2.1, 2.01, and 2.001. And just out of laziness, I'm going to call this f of x, even though it hasn't actually been named, just so I don't have to write that very small twice in there. And so then we just need to plug things in. So for 1.5, that's going to be 1.5 to the 8th minus 256 all over 1.5 squared minus 4. And there's no need to try and take 1.5 to the 8th by hand. Definitely use a calculator. I get 131.641 here. So I will put that in my table of values. And then next up, we want to evaluate this at 1.9. And again, if you've entered this into your calculator, if you have a calculator where you can enter it all in one go, you can just go back in and replace the 1.5s with 1.9s. And when I do that, I get 220.934. Now let's try 1.99. Seeing what that gives us, I've got 252.195. And then if we throw in one more 9 at the end, that gives us 255.616. All right. Now let's approach from the other side. Let's look at what happens when x is 2.5. We end up with 564.391, which is quite big. Let's move in a little closer at 2.1 and see what we get. I get 298.119. That's looking a little closer to what we got on the other side, so that's looking good. If we do 2.01, and again, I'm just entering these into a calculator, nothing fancy, 259.875. If we do 2.001, we get 256.384. It looks like in both directions, these are getting closer to 256, which makes sense. We can see a 256 in the problem, so that's hopefully not a huge surprise. I'm going to add in another 0 here just to look a little closer and see if that is looking what's happening. And I see 256.038. That's looking good. If we add in another 0, that's 4 zeros in there, I get 256.004. It definitely does look like we're getting closer to 256 on both sides. If I do 1.99999, I'm just going to throw in 5 nines there. We end up with 255.996. Yep, definitely looks like it's going to be 256. So the limit as x approaches 2 of x to the 8th minus 256 over x squared minus 4 does appear to be 256. The reason we are making tables of values and we're not just looking at one number that's above and one number that's below is because we want to see the patterns. We want to get several data points to see what's going on. We can see here that to the left of 2 on the number line, very clearly we've got a function that's increasing, but the increasing is getting, the rate of increase is getting smaller and smaller as we get above 255. And then on the other side, it's a huge number at first, but then when we get closer and closer to 2, we're getting closer and closer to 256 on the other side. And so having all of this data helps us to be more confident that it is in fact in both directions approaching 256. We want that confidence to know that the limit is correct and not just a couple of data points and a guess that very well could be wrong.